Okay, let's look at this one. I'm going to write using rational exponents. So if you take the key material here, x to the 1/2 is the square root of x, and x to the 1/3 is the cube root of x, I can rewrite x to the 2/3 like that. We're going to simplify. 4 divided by 6, that's 2/3. So we're going to add the exponents, 2/3 plus 2/3. And then here we're going to multiply x to the 4/3 to the negative third. You multiply the exponents. Bum, 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 bum. So it looks like our answer is x to the -4. The only problem is if I use my little pointer here, it's saying we want all exponents to be positive. So our final answer on this one is 1 divided by x to the 4th. Alright, so I'm jumping around. I'm just doing a couple problems. Let's do number 4. Number 4 is sort of a core thing. We are going to rewrite without negative exponents. So the first, a is 1/9. Remember, if you have a negative exponent, you can, if I was to say do a, 3 to the -2 is the same thing as 1 over 3 squared, which is 1 over 9. So a is 1/9, b is 9, c is 1/9. Let's do d right now together. So 1/3 to the -2 is the same thing as 3 over 1 to the 2. That's 9. And e is 1/9. So it looks like a, c, and e are the same. So 1/9, 1/9, yeah, a, c, and e are the same, and b and d are the same. B is 9, and d is also 9. Don't let this one intimidate you. Let me do one of them for you just to give you a heads up. So, for example, let's look at c. So it says right here that c is negative. So we have some negative number, but then we multiply it by a negative, and then we cube it. So it looks like a negative times a negative is a positive, cubed. A positive times a positive times a positive, it's got to be positive. So decide which of the following are positive or negative. Choice C, for sure, is positive. Let's do this one. This is looks like a straightforward one. It looks like I have -10 to the 3rd, but it's not -10 the whole thing to the 3rd. It's -10 to the 3rd to the 5/3. So I look at this and I say, okay, is my answer going to be negative or positive? So I look at this, and inside the parentheses I have a negative number to the 5/3. Remember, I was saying that the 3 here is like the root in the ground of a tree, right? So the root, this is a cube root. This is some negative number, cube root. Well, the cube root of a negative number is negative. So it looks like we get a negative number, so we have some negative number, and we raise it to the 5th. A negative multiplied by itself an odd number of times is negative. So in this problem, I know my answer is going to be negative. So let me put it in a different color here. Let me use blue. So I have a negative, the answer is going to be negative, and then I have 10 to the 3rd to the 5/3. Well, 3 times 5/3 is 5, so I have a negative number, 10 to the 5th, that's negative 1, 2, 3, 4, 5. negative 100,000. Alright, this is a little bit of... Wait a minute, I'm on the wrong one. Let's look at this problem. This is a little bit of a tricky problem. You can see I have a negative exponent. So a negative exponent is the same thing as taking the reciprocal of this fraction and raising it to the positive 3 over 2. When I see this, it's sort of crying out to me that 25 is 5 squared and that 9 is 3 squared. So I'm going to rewrite and then raise the entire fraction to the 3 over 2. Now if you look at my cool little thing here, I'm going to have to multiply these two exponents together, and I cannot forget to distribute this 3 over 2 down to this little 2 down here. So I get 5 to the third over 3 to the third. Okay, here's a cool little problem that seems tough, seems intimidating, but it isn't. So, I know it's sort of hard to see. Let me see if I can pinch this up. Okay, so am I still on? I'm still going. Okay, I'm just learning this program for the first time. So, nope, I guess I can't erase that. So, okay, it's hard to see, but that's to the 2/5. So I have 32 to the 2/5 times a to the 2/5 times a to the 3 over 2 to the 2/5. So you got to keep in mind here that the square root of a cubed is a to the 3 over 2. Remember, this 2 here is like the root in the ground. It's like the square root. It's the number that's right there. There's an invisible 2 for the index. So almost done. 32 is 2 to the 5th to the 2/5 times a to the 2/5 times a to the 3/5. This part right here, these can combine together. So we get a squared times a to the 1st. Look at that. It simplifies to 4a. This one I'm not going to do for you, but this one you're just going to FOIL or expand. Okay? You're going to FOIL this or expand. This one I do want to point out, if I'm not here to help you on this, the most important thing, if you look right here, people think that negative 2, the exponent, is attached to the 1. And that's completely not right. The 3 has a positive 1 for the exponent, and the r is the only term that has a negative 2. And the thing that's in the denominator, the 2r to the negative 4, that entire thing can be pulled up to the numerator and raised to the positive 4. So this r to the negative 2, that's going to move down. That's going to move down to the denominator. So that's going to be 3 over r squared, 16 r to the 4th. So if I have 2 r's in the denominator and 4 of them in the numerator, we're going to get 3 times 16, which is 48, r squared.